Hey everyone, welcome back to my YouTube channel Act 1. The anomaly. For centuries, humanity has gazed up at the night sky, charting the familiar dance of planets, moons, and stars. Our solar system, once a realm of just a few wandering lights, has steadily revealed its complexity, from the fiery embrace of the sun to the icy frontiers of the Kuiper Belt. We thought we knew its major inhabitants, a well-ordered family of 8 planets and a dwarf planet or 2. But what if that understanding is incomplete? What if, far beyond the reach of our most powerful telescopes, a colossal, unseen world lurks in the cosmic darkness, subtly tugging at the fringes of our known universe? What if our solar system isn't quite as empty as we believe it to be, and a lost planet, a true giant, is hiding in plain sight, or rather, in profound obscurity? Imagine a gravitational phantom, a celestial behemoth perhaps 10 times the mass of Earth, orbiting the sun at distances so vast that a single revolution could take thousands of our years. This isn't science fiction. It's a compelling hypothesis, a scientific mystery that has captivated astronomers for the better part of a decade. The idea of a 9th planet, a true giant, existing beyond Neptune, isn't new. It's a recurring whisper in the scientific community, often dismissed as speculative fantasy, yet persistently re-emerging whenever new, unexplained anomalies arise in the outer solar system. You've seen this before, a pattern of gravitational whispers leading to monumental discoveries. The very existence of Neptune was predicted by mathematical calculations based on irregularities in Uranus's orbit, long before it was ever seen through a telescope. Pluto, too, was sought after due to perceived perturbations, though its mass proved far too small to account for them. These historical triumphs, born from the subtle hand of gravity, fuel the modern quest. Our current understanding of the solar system's architecture suggests a relatively stable, well-defined arrangement. The inner, rocky planets huddle close to the sun, while the gas and ice giants dominate the outer regions. Beyond Neptune lies the Kuiper Belt, a vast disk of icy bodies, a cosmic junkyard of comets and dwarf planets like Pluto. And further still, stretching almost halfway to the nearest star, is the Oort cloud, a spherical shell of trillions of icy objects, the true edge of the sun's gravitational dominion. It is in these distant, frigid realms that the most intriguing anomalies have begun to surface, not as direct sightings, but as gravitational echoes, subtle disturbances in the orbital ballet of the most remote objects we can detect. These anomalies are not random. They appear to be structured, coherent, almost as if a colossal, unseen shepherd is guiding a flock of distant icy worlds. The orbits of a particular class of trans-Neptunian objects, those extreme objects that never come close to the inner solar system, exhibit a peculiar clustering. Their paths around the sun seem to be aligned in a way that defies statistical chance, and their orbital planes are tilted in an unexpected fashion. It's like finding a group of scattered pebbles on a beach, all arranged in a perfect circle, with no apparent explanation. For astronomers, this isn't just a curious coincidence. It's a profound puzzle, a cosmic breadcrumb trail leading to a potential discovery that could redefine our understanding of our own cosmic backyard. The question isn't merely whether a planet is hiding out there, but what its existence would tell us about the chaotic, violent processes that sculpted our solar system billions of years ago. The search for this lost planet is a testament to humanity's insatiable curiosity, our enduring desire to map the unknown, and our willingness to challenge even our most fundamental assumptions about the universe we inhabit. Act 2, the first clues. The hunt for Planet X has a storied history, predating even the discovery of Pluto. It began in earnest with Percival Lowell, a wealthy American astronomer who, in the early 20th century, became convinced that gravitational perturbations in the orbits of Uranus and Neptune pointed to an unseen 9th planet. Lowell established an observatory in Flagstaff, Arizona, dedicated to this very search. He meticulously calculated potential locations for this elusive world, which he dubbed Planet X, and tirelessly photographed the night sky, comparing plates to detect any moving object. His quest, though ultimately unsuccessful in finding the planet he sought, laid the groundwork for future discoveries. Lowell's work, though intense, was cut short by his death in 1916. However, his legacy endured, and the search for Planet X continued at the Lowell Observatory. It was there, in 1930, that a young astronomer named Clyde Tombaugh, meticulously comparing photographic plates taken weeks apart, discovered a faint, moving point of light. This object was initially hailed as Planet X and named Pluto. Its discovery was a triumph, seemingly confirming Lowell's hypothesis. For decades, Pluto held its place as the 9th planet, a distant, enigmatic world at the edge of our solar system. However, as astronomical techniques improved, scientists began to accurately measure Pluto's mass. To their surprise, it was far smaller than anticipated, a mere fraction of Earth's moon. This minuscule mass meant that Pluto simply could not exert the gravitational influence necessary to explain the orbital anomalies that Lowell had attributed to Planet X. The initial Planet X problem remained unsolved, and Pluto's planetary status, once seemingly secure, began to be questioned. The reevaluation of Pluto's status intensified in the late 20th and early 21st centuries with the discovery of numerous other icy bodies beyond Neptune. This region, now known as the Kuiper Belt, was revealed to be a vast reservoir of dwarf planets and smaller objects, a sort of second asteroid belt. Objects like Eris, Makemake, and Haumea, some nearly as large as Pluto, demonstrated that Pluto was not unique, but rather one of many denizens of this distant realm. This led to a contentious debate within the astronomical community, culminating in the International Astronomical Union's controversial decision in